Hey everybody, Mr. Odom here, and today I am going to go over section 3.2, adding and subtracting linear expressions. You're going to find that we've already been adding and subtracting linear expressions, though we didn't know what linear expressions were, so we didn't know we were doing it. So now we're going to talk about what a linear expression is. You're going to see them a lot this year. They're not the only kind of expressions you're going to see as you move up into eighth grade math. Those of you taking pre-algebra will see them, and we'll see them when we cover eighth grade math. And then when you get to algebra and beyond, you'll see linear expressions, and then what we call nonlinear expressions. You will see them quite a bit. So you'll need a pencil, composition book or notebook paper, and a calculator as usual. And the learning target for this video is I can apply operations or properties of operations to add and subtract linear expressions. So what are these things? What are they? Tell me. I need to know. All right, so right here is the definition for linear expressions. A linear expression is an algebraic expression, which we've been talking about in this chapter, in which the exponent of the variable is 1. So here are some examples of linear expressions. Negative 4x, 3x plus 5, 5 minus 1/6 x. Notice how I was emphasizing the x. All right, these are linear expressions because the exponent, even though it's not written here, the exponent would be 1. I could put it by the x. We just don't do it because we don't need it typically when we're working with exponents. So that's why you usually don't see them when the exponent is a 1. We usually don't write those down. All right, I think I've emphasized that enough. Well, let's look at nonlinear expressions. I'm cracking myself up here. Nonlinear expressions are expressions where the exponent of the variable is something other than 1. So here, this is a nonlinear expression because there's a variable with an exponent of 3. Here, an exponent of 2. Here, the variable has an exponent of 5. Okay, so those are nonlinear. And we're not working with those right now. We're only going to be dealing with linear expressions. Okay, so what I want you to do is pause the video here and write the definition of linear expression, which I highlighted in green. Write that in your composition book. If you're watching Edpuzzle, the video will stop now. All right, we are back. And so let's play with these things a little bit. Let's see, how can we add linear expressions? So I worked out a couple problems right here. I worked out problem number 1 and problem number 3. And let's go through these steps. What did I do? Well, the first thing I did, I wrote the problem down, and I basically look at the linear expressions. The linear expressions are inside the parentheses here. So the first thing I do is I look outside of the parentheses next to each linear expression. And if I don't see a number, okay, if I don't see a number, then I can just drop the parentheses. All right, I can just drop the parentheses. So that's what I did here. I see I have x plus 3 in parentheses, and I have 2x minus 1. There is no number in front of the parenthesis here or here, so I drop them. And then this problem looks just like problems from section 3.1. So I have to follow the steps. I identify the like terms, which I did. I put the like terms together, which I did, and then I combine them, which I did, and I got an answer. You could write the expression this way, and that's just using the commutative property of addition, which says order doesn't matter when I'm adding two values together. So The steps from, get a pen, from here down to here, that's all 3.1. That's all from section 3.1. Okay, the first part is manipulating the linear expressions so then I can work and use the things that I learned, from section 3.1. All right, let's look at another problem. Problem number 3. So in this problem, notice I highlighted here. If I look in front of the parentheses here, I see there is a positive 2. Notice I use that plus sign. I attach it to the 2, and I say that's positive 2. And I remember, because we went over this in 6th grade, that this looks like the distributive property that I need to use, because this is 2 times this quantity, negative 5n plus 3. So I need to use a distributive property. For the first linear expression, I look out next to it, outside of it here on the left, and there is no number out there. So I can just drop those parentheses. So I do, and I have 4 minus n. And then I have to go ahead and do this math. Positive 2 times negative 5n. What is that? Well, that's negative 10n. What's positive 2 times positive 3? Well, it's positive 6. All right. And then I go ahead, and from here down again, I'm using section 3.1. I identify like terms. Did I identify them? Check. Did I group them, put them together? Check. Did I combine them? Yes. Are there parentheses? No. Are there like terms? No. Then this expression is in simplest form. And there are 2 ways I could write it, like that, or I can write it like that. Okay, so go ahead and pause the video, and I want you to work on problems 2 and 4 in your composition book. And then I want you to come back and we will continue. If you're watching this in Edpuzzle, the video will stop now. All right, we are back, and let's just look at the answer. So problem 2, I did the work, and you can see the answer I got was 11. Okay, so you can see the work that I did. I can just drop those parentheses because there's no number in front of the parentheses, in front of each linear expression. Let's look at problem 4. Here, I do have values that are in front of each linear expression. So I need to use the distributive property. I'll write that down. Distributive property. Okay? Don't forget this one. It's important. All right, so I use a distributive property, and I end up here at this step. This is what it looks like when I use a distributive property right here. Okay, and then I go ahead and kind of clean this up a little bit. 1/2 times negative 6 is negative 3. 1/4 times 12 is positive 3. So I go ahead and I identify like terms. Did I do that? Check. I put the like terms together, group them together, and then I simplify them and ask myself, are there parentheses? No. Are there like terms? No. Then this is in simplest form. All right. Good. Hopefully you're able to follow along with that. Let's talk about subtraction. We're going to subtract linear expressions. Remember what we did in chapters 1 and 2. When we had subtraction problems, we turned them into addition problems by adding the opposite. We're going to do the same thing here. Okay, so when I am going to add the opposite, it really works well when I don't have any numbers here to the left of my linear expressions. Then all I do is I write the first linear expression down, change this subtraction sign to addition, and then write down the opposite of these terms. So the opposite of negative m is just positive m. The opposite of positive 12 is negative 12. And then guess what I do? Yes, I'm back. Identifying like terms? Check. Grouping the like terms together? Check. Combining the like terms? Check. Are there parentheses? No. Are there any more like terms? No. So then I put a box around it because this is my expression and it is in simplest form. So this add the opposite piece, it works. And it doesn't really matter if there's a number in front of here or not. So I want you to pause the video. Or if you're watching Edpuzzle, it will pause on its own. And I want you to work out problem 6 on your own and write your answer in your composition book. All right, so we're back. And let's look at what happened here. So this problem number 6, I wrote it down here. And what did I do? Well, first I noticed that I had these values out here to the left of each one of these linear expressions. Remember, the linear expressions are inside the parentheses. So I used the distributive property. And this is what the distributive property looks like. Okay, when I use it, it looks like what's on this line here. And then I clean this up a little bit. I do the math. I multiply negative 2 times 2.5. I get negative 5. Multiply negative 5 times 1.2c. I get negative 6c. I multiplied negative 5 times 4. I get negative 20. And I multiplied negative 2 times c. I forgot that one. I get negative 2c. Now we are back in chapter 3, section 3.1. I identify my like terms. I group the like terms together. I combine my like terms and I ask myself 2 questions. Are there parentheses? No. Are there like terms? No. So this is in simplest form. So I want to work this problem out one more time. And so let's just work this out one more time. And I want to show you that you can also add the opposite as a way to get to the answer as well. So let me write this down. Negative 2 times c plus 2.5 minus 5 times 1.2 c plus 4. Okay, let me get some room here. All right, so one of the things I can do, or one of the things I have to do, I still have to use the distributive property. So I can't forget that part, especially with this first linear expression and I have that negative 2 out there. I'm going to end up using the distributive property. But let me go ahead and let me just, since this is a subtraction problem, let me just write this down and we'll get to the distributive property in a moment. Let me just add the opposite. So think of this as negative 5, this as negative 5. So I'm going to write it as positive 5. What's the opposite of 1.2c? It's negative 1.2c. What's the opposite of positive 4? It's negative 4. Okay. And now I can go ahead and do the distributive property. Do the distributive property, right? It sounds like a dance or something. All right, so this is negative 2 times c, and negative 2 times positive 2.5 is negative 5, plus 5 times negative 1.2c, and I put plus here, but really I can erase that. 5 times negative 1.2c is negative 6c. And then 5 times negative 4 is negative 20. And I can go ahead and combine my like terms. Eventually, I want you guys to be able to identify those like terms and combine them in one step. So let me identify them. Negative 2c, and there's negative 6. So that's negative 8c, which I have up here. And I have negative 5 minus 20, which is negative 25, which I also have up here. So I get the same answer. Okay, so adding the opposite, you can also do that when you need to use a distributive property as well. So that works, okay? So you have different ways you can solve these problems. All right, so that's it for today. I know this video is a little bit longer, but this is important information that's going to help us when we get to the last few sections in this chapter and we are solving equations. We're going to find that we might need to simplify our expressions first. All right, so this is Mr. Odom, and I hope you have a great day. And I'm going back to the top for no reason whatsoever, except to say, hopefully you feel comfortable doing this. And if you don't, ask me questions. Bring your questions to school and ask me when we're in Google Meet or in the classroom. All right, you guys take it easy. Bye.